Hello, this section is about framing. The data link layer must use the service provided by the physical layer in order to provide service to its upper layer, the network layer. But the physical layer is only able to put raw bit stream on the transmission media. Raw bit stream is not guaranteed to be error-free, so it is up to the data link layer to detect and, if necessary, to do error correction. In order to do error detection and correction, the data link layer should be able to break up the bit stream into discrete frames. When a frame is transmitted, the sender needs to compute the checksum for each frame, and the checksum will then recompute it when the frame arrives at the destination. Breaking the bit stream up to frames is somewhat difficult. You probably think it should be easy because we just need to insert time gaps between frames. But the thing is, if you just use time gap, you won't be able to distinguish it is a time gap or it is just idle. So we need to look at other methods of donating the start and end of a frame. So now we are going to introduce 4 framing methods. The first one is called character counter. Second one, the flag bytes with byte stuffing. And the third one, starting and ending flags with bit stuffing. And the fourth one is about physical layer coding violation. So we start with the first one, character counter. We have explained it is impossible just inserting time gaps between frames, but we can use a field in the frame head to specify the number of the characters in the frame. So this is a method we can sort out the problem of framing. In this example, we say we use the first character of the frame to indicate the length of the frame. But the problem of this method is, if we get transmission error, if the first character being converted to other values, then all the following frames will be messed up. So let's try to say other methods. So this method we're going to explain is called flag bytes with byte stuffing. We use a flag to indicate the start and end of the frame. But the issue is, the flag, it might occur again in the payload field, in the data field. So we will do byte stuffing if the flag appears in the data field. So we use a special character to indicate this is a flag or this is a real data. So if a flag appears in the data, we insert a special character in front of it. If this special character, if this special byte appear in the real data, we can insert another special character in front of it. The third method we are going to explain is called flag bytes with bit stuffing. It allows data frame to contain an arbitrary number of bits and allows character codes with an arbitrary number of bits per character. So imagine that each frame begins and ends with a special bit pattern. In this example, we use 0 and 6 ones and 0 as a special pattern. Whenever the sender's data link layer encounters 5 consecutive ones in the data, it automatically stuffs a 0 bit into the outgoing bit stream. With bit stuffing, the boundary between 2 frames can be unambiguously recognized by the flag pattern. So here is an example. In this example, in the payload data field, we have 15 ones. So when the sender sends out this bit stream, the sender will automatically insert a 0 after 5 consecutive ones. when the bit stream being received by the receiver will scan the data again. If it finds 5 consecutive ones, it will try to find out whether there is a 0 following. If there is a 0 following, then the receiver will automatically remove the 0 and convert it back to the original bit stream. The last method we are going to explain is called physical layer coding violations. It is only applicable to the networks in which the encoding on the physical medium contains some redundancy. For example, some LANs encoding 1 bit of the data by using 2 physical bits. Normally, 1 is a high-low pair, and a 0 is a low-high pair. In reality, most data link layer protocols use a combination of character counts with another method for extra safety. This can increase the chance of catching an error. That's it for this section. Thank you.